Imagine you work at a company where millions of events are coming in every day: clicks, orders, payments, logs, and your manager asks a simple question: what are the top 10 products right now? You run a job and it takes hours. By the time the result comes, the business already changed. Hello everyone, I am Pranit. Welcome to Big Data Factory. Today, I will explain what Apache Spark is, why the world moved from Hadoop MapReduce to Spark, and most importantly, Spark architecture. Its drivers, executors, cluster manager, DAG, jobs, stages, tasks, in a way that actually sticks. Let's go back to the old world of big data. Back then, the king was Hadoop MapReduce. MapReduce was revolutionary. It could process huge data in clusters, but it had a problem. It was designed mainly for batch processing and it wrote to disk again and again. Here's what happened in real life. You didn't run one MapReduce job, you ran many jobs in a chain. Job 1 writes outputs to HDFS, job 2 reads it again, writes again, reads again. That disk input output becomes the bottleneck. And not just that, modern workloads needed things MapReduce wasn't built for: interactive analytics, iterative algorithms, faster ETL without constantly dumping to disk. So teams started asking, is there a faster engine that can keep data in memory and still scale? And that's where Spark enters like a superhero. Spark's big idea is simple. Instead of writing to disk after every step, Spark tries to keep data in memory and builds an execution plan. And one misconception: Spark did not delete Hadoop overnight. Spark often runs on top of Hadoop storage like HDFS and uses the same cluster resources. So when people say we moved from Hadoop to Spark, they usually mean we moved from Hadoop MapReduce compute engine to Spark compute engine. If I had to define Spark in one or two sentences, Apache Spark is a distributed data processing engine used to process large amounts of data quickly across many machines. It works by splitting data into parts, processing them in parallel in memory, and coordinating the work using a central driver. Because of this in-memory and parallel execution, Spark is much faster and more flexible than traditional disk-based systems like Hadoop MapReduce. And now, the architecture. This is where most people get confused, so I will explain it as if we are watching a job travel through the system. There are four main characters in Spark architecture: driver, executors, cluster manager, and storage. Character 1 is the driver. The driver is the brain of your Spark application. The driver does things like starts your Spark session, turns your code into an execution plan, splits work into smaller units, sends tasks to executors. If the driver dies, your application usually dies. And the character 2 is the cluster manager. This is the system that gives Spark resources. It could be Yarn, Kubernetes, Spark Standalone, Mesos. The cluster manager's job is simple. Here are machines, here are CPU cores and memory, use them. Character 3, executors. Executors are processes running on worker machines that actually do the work. They run tasks, keep data in memory or cache, write shuffle data, report results back to the driver. So remember this: driver coordinates, executors compute. And character 4, storage. This is where your data lives: HDFS, S3, ADLS, GCS, whatever. Spark reads from storage, processes data, and writes back. Now let's press play. You run a Spark job, maybe Spark submit, or you run a notebook job. That's the client. When Spark submit is done, Spark context gets created in which it runs driver program, which submits the job to the cluster manager, which in turn communicates with each worker node. In simple, the client launches the driver, driver talks to the cluster manager launches executors, and now the real magic starts. The most important Spark concept: DAG plus lazy evaluation. In Spark, when you write code, Spark doesn't always execute it immediately. This is called lazy evaluation. Spark first builds a plan called a DAG, a directed acyclic graph. Think of a DAG like a recipe. Spark reads your transformations and say, okay, first filter, then group, then join. Before moving further, there are two big terms in Spark you need to know: transformations and actions. Transformations in Spark are lazy operations that define how data is transformed into a new data set without immediately executing the computation. Actions just trigger the execution. So when you see in the code, we initially read the data and When we read, it won't perform immediately. There are a couple of transformations applied on this input data. We rename the column, we join with different data sets, and transformations, these are transformations which won't act immediately. They wait till an action is encountered. When they encounter an action like count, show, write, they execute all the transformations which are in line. So whenever this write is an action, whenever this is encountered, this action will trigger all these actions which are in all these transformations which are in line, and it will be performed. So after we run the job or we submit the job, the actual execution starts only when an action is called. An action such as count, show, or write triggers Sparks to submit a job. A job represents the complete execution required to produce the result of that action. Internally, Spark divides the job into multiple stages based on shuffle boundaries. A stage is a set of operations that can be executed together without requiring data to be redistributed across the cluster. So, what causes stage boundaries? Usually, a shuffle. Like a shuffle means Spark has to move data across the network. Like when you do a big group by or join, so Spark says, stop, we need to redistribute data. That becomes a new stage. Event stage is further divided into multiple tasks where each task processes exactly one partition of data. These tasks are the smallest unit of work in Spark and are executed in parallel by executors on different worker nodes. So, in simple terms, an action triggers a job, the job is split into stages, and each stage runs multiple parallel tasks on partitions to complete the computation efficiently. Now we go through why Spark is resilient and why it's called fault tolerance. Now, what if a machine fails mid-job? Spark has a strong idea called lineage. It remembers how your data was created, the steps in the DAG. So if one partition is lost, Spark can recompute it from the original steps instead of giving up. This is why Spark's core abstraction was called RDD, Resilient Distributed Dataset. As it can recover from the original steps, that's why Spark is called fault tolerant and resilient. And we have a Spark UI concept. This is the best part. Like we can we can see all jobs, stages, task, shuffle size, and which step is slow in the Spark UI. If you want to become strong in Spark, the Spark UI is your best friend. So let's close the story. We came to the end of this video, and today we have gone through Hadoop, why we went from Hadoop MapReduce to Spark, because Hadoop MapReduce was disk heavy and slow for multi-step pipelines. But Spark builds a DAG and optimizes execution. It keeps data in memory when possible, and it's faster than MapReduce. And it supports modern workloads like SQL, streaming, ML, ETL. And we also went through the Spark architecture, and we also went through the what is fault tolerance and the Spark UI and the job stages task and everything. And that's the end of this video. Please do like, share, subscribe to my YouTube channel, and do let me know in comment section what you feel about this video. We'll meet in next video. Till then, bye bye.